Hello, everybody. My name is Paul Gagliardo. I'll be your moderator today. Just so you know, I've been in the water business for 35 plus years. I'm the host of the Water Entrepreneur podcast. I'm a registered engineer and also have a master's in public health. This webinar is part of a series being put on by AWWA to talk about leak detection and remote Earth observation technology and how it can assist water utilities in managing their assets. Traditional leak detection approaches are often localized, labor-intensive, and can make it difficult to assess priorities system-wide. As utilities seek broader, data-driven strategies, satellite-based technology combined with AI analysis has emerged as a proven tool that can detect potable water leaks up to 2 meters below ground and across large geographic areas of up to 1,000 square miles in a single satellite pass. This webinar will discuss how these technologies are being integrated into utility operations to support system-wide monitoring, prioritize field investigations, and informed decision-making. We will hear from the City of Duncanville, Texas, who will share how they've leveraged this advanced technology to identify 80 leaks in just 15 days. This webinar will also explore how the same technology can be applied to monitoring critical infrastructure, such as earthen dams, levees, and canals. By identifying subsurface soil moisture anomalies, this approach supports inspection programs, enhances safety consideration, and contributes to long-term asset management. Now, let me introduce today's speakers. First, we have Matt Bryan, Director of Public Works at the City of Duncanville, Texas. Next, we have Eric Triaratola, Senior Sales Manager at AWWA. And finally, we have Gary Eaton, Executive Vice President for Operations at AWWA. So I just want to go through the agenda real quickly. As I said, our main focus today will be on the City of Duncanville, Texas. We'll explore how they use the AWWA technology to reduce non-revenue water in their system. AWWA will also discuss how the use of AI improves the efficiency and ROI of leak detection programs. And finally, AWWA will discuss how the remote Earth observation technology can also assist utilities in the management of other infrastructure assets, including earthen dams, levees, and canals, rail lines, and roadways. So let's start with Matt. Hey, Matt, how you doing today? Can you tell us a little bit about the City of Duncanville, where it is, how many people you serve, how many miles of pipe do you manage, that kind of thing?
Sure, thank you. Hey, everybody, hope you're all having a good day. So Duncanville, back in the late 1800s, railroad came through and we built a rail stop known as Duncan Switch. We still have an open market periodically to honor that. We're 11 square miles, got about 40,000 residents, incorporated in 1947, and our governor, Greg Abbott's actually a high school graduate at Duncanville. And so we took advantage of this just because we noticed a significant water loss. And so when we heard about this opportunity, we couldn't wait to jump on it.
Great, thanks, Matt. Let me ask you a question. Do you treat your own water or do you buy it from others?
No, we currently purchase all of our drinking water from Dallas Water Utilities, so we don't have any treatment process here. We have the ability to boost and inject chloramine, but we haven't had the need to for some time, so pretty much it's just purchase and sell.
And I'm curious, in Texas now, are there water supply issues? There's a drought everywhere in the Southwest. I'm assuming that the cost of buying treated water is also kind of expensive. Are those two of the drivers for you to reduce your non-revenue water?
Yeah, not so much in this area as much as West Texas for sure, but there's always a rising cost of treatment and the treatment process that is. And so anytime there's that rising cost, we're forced to pass that on to the resident. So every drop of matter waters, right? And we have state flushing that we're required to do. So there's some known loss to that, but just not realizing where the water is going when you take it in. We struggled with that a lot for several years.
And I recall that the state of Texas has everybody monitor and report on their water losses and those kinds of things. Is that something you guys do like on a yearly basis?
Yeah. So we're all required to submit water loss surveys and water loss reports, audits to the Texas Water Development Board. So during those reports, we just noticed gradually over the last probably 5 years, we used to have, 10 years ago, very, very good water loss audits. We were probably within 5 to 8%. And then just gradually over the last 10 years, we've seen it get significantly higher and higher and higher to the point of, upwards of 30%. And so it became really alarming, doing everything we could in-house to figure out what was going on and where it's going. We have a unique soil here, so it's hard to ever see it. And just the amount of manpower and labor hours involved in tracing down these leaks was astronomical.
There's a lot of places with sandy soil where the leaks just go straight down and they never surface and you never see them. I'm sure that's similar to what situation you've got. Is that correct?
Oh, absolutely. So Duncanville is primarily rock. We get a lot of rock channels where our trenches were cut for the pipeline. So anytime a pipeline's leaking, it generally just stays underground and travels that trench, and it's in the creek without us even knowing about it. We've even had an instance, just a fortunate situation, walking by a storm drain on an August day and could hear trickling in the storm inlet when it hadn't rained in weeks. If we hadn't have been in that situation at that time and heard it, that leak would still be going. And so we know for a fact that's happening. And it's just, where do you start? How do you find it?
And do you guys, before Astera, did you have a proactive leak detection program? Did you send your folks out on a periodic basis to do acoustic analysis, or were you just responding to the leaks that did surface?
Well, to the best of our ability. I think we struggle with employee retainage and vacancies just like everybody else. So when we had the manpower and the time, we absolutely would. We just randomly send people out because we don't have any sub-metering or anything either here. So we have no way of knowing what part of town the leaks are happening or where the highest usage is. So it would just kind of be a random, go to this area and check it out. Maybe starting with our oldest infrastructure and our oldest parts of town. And but outside of that, we're chasing them as they surface, and so we invest so much time and energy in repairing actual main breaks that are bubbling up that we can find that there was generally little to no time to do any preventive investigations.
And is most of your pipe metal pipe? You have a mix of plastic and metal. What's your asset base?
So most of our infrastructure is a combination of ductile and cast. We have an old part of town up north. I've been told it was annexed decades ago. I don't know how true that is, but that's primarily asbestos cement pipe, and it's really shallow. Oftentimes, if we have a main break up there, we just send guys up there with a few shovels because it's literally 12 to 15 inches deep. The AC pipe has actually been pretty reliable. I know it kind of has a bad rep because of the name, but actually it's a fairly reliable infrastructure, and we don't deal with breaks or leaks up there too often. But the cast is definitely an issue, and the ductile is an issue, and that's probably 70% of our infrastructure.
So what challenges were you looking to resolve when you decided to hire Aster and develop a proactive leak detection program? And what were your overall goals?
Without a doubt, leak identification, right? So again, we just really didn't have the manpower or the resources to go find it. If we did, it was absolute luck. But this ability to identify all areas of interest and then even still follow that up with boots on the ground acoustic leak detection, so that now my crews have the information they need to just move on it. I don't know how we can do without it.
So I understand you started at Duncanville almost 20 years ago as a maintenance worker. Did you ever think that you would be looking for leaks using satellites when you first started?
No. That's for Google Maps and Waze and stuff, right? No, I never imagined this technology would ever exist, to be honest with you. I had always, I've seen the progression of technology, so always optimistic that something was out there, but this turnkey and this much information, no, I never imagined this would be even feasible.
Great. Well, thanks. So now we're going to move and talk a little bit to the Aster folks about exactly how the process works. So Eric, why don't you give us a quick overview of the satellite-assisted leak detection program and how it works?
Sure. Basically, Aster is using several different commercial satellites that are in a polar orbit, so orbiting the planet every 90 minutes. They do not take an image unless we commission them to, so everything's fresh. We're not using old archive data. And on the left there is actual satellite image from our largest kind of aspect rate, our square miles, and that's San Francisco Bay, and it's about 25 miles east to west, 45 miles north to south. So the opportunity to image a single utility in an image is great, but then not only that, but neighbors. With Duncanville, we did another city called Burleson, Arlington. So the opportunity to share that investment is possible. But really, the most importantly is we can capture in a single image a given utility, typically. And what we're using, synthetic aperture radar. It's extremely sensitive to water. It shows all types of water subsurface. The way our technology works is we need to penetrate the ground and see the soil moisture, and then get the return back. Synthetic aperture radar, if we think about radar, the R part of radar stands for radio. And radio, that's all we're doing, is we're emitting a radio signal, or the satellite is doing, emitting a radio signal down to the planet, and then getting the return back. Very similar to the way dolphins use sonar, bats use echolocation, the exact same principle. But most importantly, we need to penetrate the ground. Typically surface leaks, that surface leak will act as a mirror, and it bounces right back up into space. And unless it's a really big leak, we're not going to see it, which seems silly that we're so high tech and we can't find the surface leaks. But you know what? That's what most utilities can find themselves. 50%, but the issue is 50% of the leaks never surface. So that's what we do, is we help find those hidden leaks that never surface, and it's very, very complementary. And another thing we're using, in the world of synthetic aperture radar, that's quite wide. We're using L-band. It's not used nearly as much, but it gives us the depth penetration to up to 10 feet. And which is great because that's where most of the distribution lines are. Even if they're a little bit deeper than that, usually through capillary action, they leak into that area. Still might not surface, but we can actually capture that water within that 10 feet. A lot of the other bands, they're just barely breaking the surface, 1 to 2 centimeters, and that's about it. So the chances of finding that water, they're really looking for suspicious vegetation. Then we go ahead and after we see all these different types of water, one of our patented technologies is our analysis and our ability to differentiate the different types of water. So in other words, we can actually see potable water and separate it from wastewater or regular groundwater or seawater. It's very unique to Astera. No one else is doing that part. That's kind of it in a nutshell.
So, Eric, how often does the satellite cover the same area of the Earth?
Every 90 minutes. Every 90 minutes, it's
the same.
Yeah. So, but not the exact same angle. Every 90 minutes, we're getting it. But as the Earth is rotating, which is how we're getting our coverage, it's going round and round the planet. Every 2 weeks for each of the different satellites, it absolutely repeats the exact same process. We could get the exact same angle. That's every couple weeks.
And how long does it take from the time you collect the satellite image, do the analysis, and deliver information to the client? How long does that typically take?
Well, the longest part is scheduling the satellite. Once we get the image, and that's typically for about 4 weeks, it can be up to 4 weeks. But once we get the scheduling, it's just within 5 days. We can do the analysis. So once we get the image, it's in our hands. It's just a few days, and we get that data right back to them.
Great. So let's talk a little bit about the results that you were able to achieve here in Duncanville. I understand that worldwide, Astera has found almost 200,000 leaks since you began commercializing this technology. Maybe you can give us a little rundown on kind of the points of interest that you found and how many leaks you found.
I'm sorry, it just cut out right when you were talking. Just go over the results.
No worries. Yeah. Just give us an idea of what kind of results you got in Duncanville.
Yeah, no problem. I saw my camera wasn't working, so I decided to reload it, and it just fried everything. But anyway, I'm good. So the results, one of the things that we know is, 50% of all the leaks occur in 10% of the system, and that's what Astera is. We're not a pinpointing technology. We're more of, I always say, we can't find the needle in the haystack. We show where part of the haystack to be searched. And with Duncanville, we basically scanned and we provided, rather than 240 miles that you would have to walk and use all the technician's time, and with the technician shortage, it's very tough to even do a proactive leak detection. We narrow that down to about 24 miles to be walked. And as you can see on the picture there, you can see the different parts where the different points of interest or likely leak locations, and you can see the results of them. The areas that are quiet are grayed out, kind of goes to the background. Really focusing on where we're seeing there. We found a total of 80 different leaks. You can see the 80 different leaks in the dark blue. The ones that are an aqua droplet, those are actually repaired leaks. And so you can see at the top in kind of real time from the boots on the ground investigation, that you can actually see how they're going about and doing the investigation. And based on what they're finding, it all rolls up to how many gallons. So we already know 102 million gallons of water saved. And then you also have the cost associated with that. So the payback period in this case, not including the repair, was way less than 6 months. So just a huge payback period. They had phenomenal results in Duncanville. And it was great over there. And they could also true up their numbers too.
How many? Do you know offhand how many of the leaks were non-surfacing out of these 80 leaks?
It was a lot. As I mentioned, the technology really needs to penetrate the ground. In Duncanville's case, it was 99% of them were not surfacing. So those are the pesky ones that disappear. Like Matt said, they get into that trench and they never surface, but then they move. So even if you do see moisture, it's probably not anywhere near where it was leaking. Also, I just want to talk about those quiets. Typically when we do a scan, we say we're 90% confident there's a leak there. Doesn't necessarily mean, because we have to rely on the acoustic method of verifying that leak. We can see a leak as small as 0.2 gallons per minute. Doesn't mean you're going to be able to acoustically verify, which is okay, because you probably wouldn't want to fix a leak that small anyway. So, the whole key is how many leaks per day, how many that you'll find with the technology, versus just blindly, unguided walking the system.
Can you also see leaks on the customer side of the meter?
Yeah, we can see on a service, we can see customer side, as well as the utility side. We can't differentiate the difference. When we create a point of interest, it's about 300-foot radius, 600 foot across. So that's kind of like the search area that they're going through. Then when it's acoustically verified, that's when they can differentiate. If it's on a service line, once they pinpoint that, then they can tell, okay, is this on the customer side or is this on the utility side? Obviously, the utility cares about the utility side, but then we're all caretakers of water, and providing that information to their clients is a pretty good PR. Saving the water for them as well.
And I'm curious, so you talked a little bit about, the L-band radar and how it can detect water. Can it differentiate between potable water, naturally occurring water like high groundwater table, and maybe reclaimed water? Is there a signal that identifies each of these kinds of waters?
Yeah, our secret sauce is how we're able to differentiate the different types of water. Like I said, synthetic aperture radar is extremely sensitive to water, and the importance of separating and differentiating the different types of water is most important. Otherwise, we could just tell you, where it rained, which wouldn't be terribly helpful. But how we're doing that is through dielectric constants. So when you treat water, that is, when you put chlorine, chloramine, or fluoride into the water, it changes that dielectric constant, or its ability to conduct electricity ever so slightly, ever so slightly. And it's that long wavelength, that L-band that we're using, that we can actually start to see the breakdown in the separation from potable water to the regular groundwater to seawater, which certainly isn't the problem in Duncanville, but wastewater as well. Wastewater is very different, and in aggregate is very similar across the planet, and we can actually differentiate that as well.
And do you guys own your own satellites?
Not yet. Nope. Right now we're using commercial satellites. We have several different commercial providers that we use to get our coverage, but the cost of satellites is going down, and eventually I could foresee someday possibly getting a purpose-built satellite for our own needs. But right now we're relying on the commercial space industry.
And can you give us a little idea about how the 102 million gallons, I'm assuming that's 102 million gallons over a yearly period, were saved? Do you use any standardized leak sizing data?
Yeah, great question. So when a leak is actually verified, that is, the boots on the ground team goes out there and says, okay, I heard a leak here. What is it on? Is it on a service line? Is it on a hydrant? Is it on a meter box? All of these things have averages that AWWA provides the M36 manual. So we actually have those averages. That's the numbers that's rolling up as a default. However, let's say if Duncanville said, if Matt said, what, I want to true these up to Duncanville's numbers, averages could be higher, could be lower. It's an average. They can actually put in their own numbers, and so that way it's more accurate to what Duncanville or whomever experiences. So that can be changed, but default, if they don't do anything, it's the M36 manual by AWWA.
And so after the satellite image is collected, a field inspection crew, whether it's a contract crew or a city crew, goes out and identifies the leak. Is there a way, before you dig the street up, to estimate, which are the worst leaks, the biggest leaks that had the biggest consequence of failure, maybe, and so therefore should be fixed first? Is there a way to prioritize things?
Yeah, with us, it's not necessarily in a vacuum can we tell. We can't tell the difference between a small leak that's been there for a long period of time. We don't know, from a bigger leak that's been there for a short period of time. Remember, it's, satellites flying over very quickly, 17,500 miles an hour. We really can't get that data. However, you bring up an interesting point. Our data can be brought right into Esri, Diamond Maps, whatever your GIS platform you're using. So if you're calculating consequences of failure, you can then see where is it overlapping where the actual failures are coming in at. You could look at bring in your work orders and see kind of where the hot spots are. We're also doing multiple scans as well. Typically we'll do 2 scans. And so you can start to see the overlap of where I'm seeing, which will help out with the prioritization. But like I mentioned, it's very complementary. So we could actually take in that consequences of failure, likelihoods of failure to help prioritize it. But just one satellite scan by itself flying over, no, it's really a combination of all the data.
Great. Thanks, Eric. Hey, Matt, can I ask you a question? Once the Astera provided, the POI, the point of interest maps, the likely leak locations, what was the process that the city took from there? I believe you guys did your own, that's a question. First of all, did you do your own boots on the ground field inspection, or did you contract? And then, what did you do with the data once there was an X on the ground saying, hey, we think there's a leak here?
So we didn't really have the available manpower to do that. So we were happy to contract for that service. That was very beneficial for us. And so they were actually able to provide us the estimated gallons per minute. And so we were able to sort those and prioritize those that way. That's why in the screenshot, you'll see the blue drops are representative of active leaks. And those are very minor. Most of those are very small service leaks, and we're continuing to get those done as quickly as we can. But thankfully, we were able to get the bad main, actual main breaks that were substantial loss and get those prioritized. Another thing was we were blown away at how many were actual simple fixes. Fire hydrants not properly seated. And they were actually pinpointed like this is on the hydrant shoe. And so it was just go out there, exercise the hydrant, maybe do some quick service on it, and then that leak is fixed. Had no idea those were even happening. And we had I want to say 15 or 20 of those. And then going back to the customer side leaks, we probably had 20, 25 that were on the customer side. So I was able to print that report, give that to utility billing. Hey, go notify the owner and replace the meter because, that's a quick capture, right? So a substantial amount of our results were super simple, and we would have never have known that. So,
Astera reported around 100 million, gallons a year. So you divide that, you can figure out gallons a minute, gallons per day. But are you able to quantify, say with your master meters, a value either from standpoint of water loss reduction or money saved? Have you been able to calculate that yet?
Well, I will say the results they're giving us is par for the course. I haven't quite captured it yet. I've been tracking it for the last 5 years. So obviously there's peaks and valleys with your pumping every year from high demand, low demand. And so it's hard for me because we just did the scan to quantify it so far because we're kind of in that valley, coming down into that valley anyway. But I will say we have a known loss of give or take $1 million a year. So It's definitely par for the course, the results we got from Astera.
So what are your main takeaways from this program?
Man, it's so refreshing to get something like this for sure. It gives us the tools we need to solve as much of our water loss as possible. It's able, I can make much better decisions. My crews are so much more efficient. So it's truly been a game changer for us. And while I know you can't guarantee the results for everybody, we were blown away at the results we got for sure.
Great. And just, do you have any advice, for other utilities who are thinking about a proactive program? How, like for example, how did you make the decision to use Astera as part of your process?
Well, it was. It's not a crazy investment, I'll say that, but also, we were willing to give it a try, and I'll tell you, my utility superintendent below me was probably your biggest critic. He's sold on it for sure. So it's definitely worth the try. It's definitely produces, and I think you'll be amazed at the results you get. And how that
Great.
can help leadership.
Great. Thanks, Matt. So remote Earth observation can be used for a lot of different things, and this particular L-band radar system looking for the presence of wet soil can be used for a number of different things. So I want to talk to Gary about using satellite monitoring for other purposes. Gary was previously the Director of Operation and Maintenance at the San Diego County Water Authority. So Gary, can you go through some of the other ways that this particular technology can assist utilities in managing their assets?
Sure, Paul. Thanks.
Thank you. Oh, perfect. He is there.
Yeah, we had some technical difficulty here with service. Anyway, thank you, Paul, for the opportunity. Earthworks is Astera's subsurface moisture detection solution that's designed for large-scale civil infrastructure, similar to what you see here: dams, levees, roads, rail, mining, and even properties. So very large properties such as airports and so on. Today, though, we want to focus kind of around the application of earthworks for dams and levees. Just like we do with leak detection, earthworks uses L-band synthetic aperture radar, which Eric went through just a few minutes from satellites. That wavelength, the L-band SAR, allows us to penetrate the Earth up to about 10 feet. So in simple terms, earthworks kind of shows you where moisture is and where it shouldn't be, and allows you to take active and to be proactive in identifying it. Okay. If you want to move to the next slide, Paul.
Sure.
Oh.
There you go.
So then the question goes, why does it matter? So essentially, these types of assets, specifically dams, levees, embankments, they're all vulnerable to the same failure mechanism. That's uncontrolled seepage that leads to internal erosion. So the challenge is that seepage usually begins long before you see anything that's on the surface. So by the time you see cracking, slumping, sinkholes, you already have a very serious issue. So earthworks gives owners and operators the ability to identify these developing problems, oftentimes weeks, months, potentially even years before they surface. And that value is huge. It's pretty straightforward. It's early detection of geotechnical risk. It's the ability to prioritize and focus your inspection assets on areas where you suspect the greatest problems. All this leads to improved safety and compliance. And then also, and really critically, a longer asset life with fewer surprises down the road. So for agencies that are responsible for dams that and levees that are aging, and many of them in the United States in particular are between the years of 50 years and 80 years in age, this early warning capability is really essential. So next slide, Paul. So now we want to talk about how it works. Well, Eric, I think, gave a very good presentation earlier about how synthetic aperture radar works. But essentially, we're using that same L-band SAR, and then we employ an algorithm that analyzes then that subsurface moisture and looks particularly for moisture patterns as well. These anomalies then we translate onto a map. And what you see on the right-hand side of this slide is a map. And what it shows you are alert areas, and those are in yellow, and alarm areas with the highest amount of soil moisture shown in red. What we do when we initially get this area of interest, this particular, in this case, a dam, we grid it off, and that's what you see are grids here. And that allows us, if we take say an image once a year, but if we take an image twice, 3 times, 4 times a year, we're able to go back to that exact grid. And we can also spot trends. So we can see if over time that area is getting more and more moist, or that pattern is tending to spread. So this allows then inspectors, dam owners, to go out and take a look at these areas and more accurately pinpoint where to spend their resources to address an issue. So it's essentially the same application as we use for recover, but it allows us to address potential soil issues instead. Next slide. So yeah, so there, when we look at benefits, they can be summarized as providing operators really with proactive asset-wide visibility. And this is particularly important when you're looking at assets that are linear, such as levees or railroads or roads they're very large and have a lot of surface area. It provides then this satellite large area information that allows you then to go address those subsurface risks, helps reduce your overall risks, helps you optimize your field inspection, helps you address it in a more proactive manner at the earliest stages when it costs you the least amount of money to address the problem. And then, of course, the biggest benefit is improving public safety down the road. And with that, Paul, I'll turn it back to you if you got any questions.
Okay, great. So one, I want to thank our panelists. Really nice job. You can see here they have your contact information. So, and I think you can download the slide deck so you don't have to busily write these long red email addresses down. So definitely feel free to contact any one of the panelists. You can certainly feel free to contact me. Also, you can see on the left-hand side of the slide where Aster will be over the next few months, at what conferences they'll be at. So if you're in any of those particular locations, you can come and visit the folks and say hello. So now we'd like to do some questions and answers. So we've got quite a few questions. One of the things I wanted to ask Eric, you guys have found over 200,000 leaks worldwide. Have you been training the model with some kind of, artificial intelligence, machine learning programs to try to improve the performance How have your scientists been implementing the AI boom? Are you using Claude or ChatGPT? What are you guys using?
Certainly not working Claude or ChatGPT, but that's an interesting point. When you have machine learning or AI, it depends on, it really needs data. Without it, it's kind of useless. So you almost have to see, over and over again, certain examples of something. So that way the computer, the AI, could actually learn from it. We had to actually create our own data tables to train it. So we started off in a very manual process of looking at it. Our technicians, looking for the signatures of water. Over time, it has gotten better. As you mentioned, we're sitting at about 200,000 verified leaks. All of that data of the conditions and the soil moisture and the amounts of chlorine, chloramine, and or fluoride or waste, we're all of a sudden now can start to see certain patterns emerge with that large sample size. And now we reached to the point where, if I think of our own production kind of as a legacy versus the AI, the performance now of the AI is actually outperforming the legacy. But it's not something you can say, let's go AI, and without the data sets. It's very important you have those data sets first. Otherwise, the AI doesn't know anything about it.
And just to be clear, is this Aster program is available globally? You can do services in Japan, in India, any place you want?
Anywhere. Yeah. It's there's really no places that it can't be used. Absolutely, wherever there's people, it could be used, obviously. I think there are some, to be technical, there are some places on the North Pole and the South Pole that's not going to be used, but Santa knows where they're at. He knows who's not.
So how about, speaking of cold climates, does the system work better or worse in northern climates during the winter, in southern climates during the summer? Is there any, seasonal impact or impact, say, for snow or vegetation or anything else?
Not really. We can see through vegetation. We can see through trees, bush. We can see through the ground, asphalt, concrete. The only thing we really can't see through is metal. As far as snow, actually frozen and arid, we can see the deepest, believe it or not. Snow, we can see right through it. I would say if you had a hurricane or something, beyond normal weather, could be a problem. Again, I mentioned before that, when we send that radar image down, that radio signal sometimes can bounce back off. So if you have incredibly saturated, like I said, tropical depression, type weather or hurricane, not a good idea. But other than that, normal weather, no problem at all. Snow, no worries. Doesn't really matter the time of the year. I like to think of it as, when do you want to go out into the field? You probably don't want to do it just before winter sets in, because your people will freeze. So do it just early spring when it's warmer. That's what I would say.
So Matt, let me ask you a couple of questions that came up. How deep typically are your pipes? You didn't mention that in some areas they're very shallow. Did you notice a difference in leaks location based on soil, based on depth to pipes? So one, how deep are your pipes? And two, did you notice any difference based on those shallower areas?
Yeah, so on average, they're 4 feet deep, except for that one neighborhood where the joke is the mains are installed by mule and plow, because that's about as deep as they are, the AC lines. No, it was pretty sporadic. I will say it typically aligned, the leaks that were discovered aligned with the known ductile and cast infrastructure. So those were kind of the assumed issues anyway. But the shallow mains actually, and a lot of this may just be because of the material, they seem to be holding up okay. AC will typically, well, for us, we find most of the leaks to be the collar of the AC pipe, in which we can just cut the collar off and slap a clamp on it. So that's not a big deal. but typically we're not responding to many of those. It's typically always the ductile and cast.
How about on the service lines? Do you have any service lines in your system? Lead service lines in your system?
Not that we know of. We're still wrapping up that second phase of the lead service line, and so we're about to initiate the potholing to confirm the actual service material. We've never allowed any, lead goosenecks or anything like that in the many decades that, personnel I've been here or personnel that I've known have been here. We've never allowed anything like that. So we're confident that we're not going to have any issues. Majority of our service lines are copper. In some older parts of town, it's galvanized, but that's pretty much the only two options, other than we're installing poly now. So everything for the last maybe 10 years that's gone in or so has been PVC main and poly service lines.
And did you find more service line leaks than mainline leaks, or about the same? What was your percentages?
Close to the same. It was probably about 50-50. But I will say the majority of our mainline leaks were surprisingly simple stuff. Like I said, fire hydrants, not properly seated, and a significant amount of our service lines were on the customer side. So again, that was an easy, let the resident be aware of the situation and then replace the water meter, because obviously the water meter, because the boots on the ground even said, we've pinpointed this on the customer meter and the meter is not registering it. So there you go.
I'm going to ask you a technical question here. Do you guys calculate a infrastructure leakage index? Does the state force you to do that?
I mean, other than we have our water loss audits and stuff that we do report. So I'm not aware of any other indexing or reporting that we do other than, we do it just for our own benefit and our own interest and to maintain transparency with the council and the residents. But the annual reports to the Texas Water Development Board is typically all we're doing.
Great, thanks. Hey, Gary, I had a question for you. You're talking about dams and levees. How about shoreline dikes? Is that something, where you've got, seawater and fresh water and a dike there? Is that something that the system can detect the moisture going one way or the other?
Yeah, over time, Paul. So if we imaged it multiple times, those grids would change then in alerts and alarms, and it would give us an understanding. Remember, we go out to the field and calibrate these satellites. We use volumetric water content. So when the satellite came over, we dug up the soil, we figured out, then we took it, the ASTM tested it, and then that's how we calibrate. So we have a good understanding over, particularly with trends, what's going on in a specific area.
Great, thank you. Eric, how is the points of interest or likely leak locations, how is that data layer delivered to the utility?
So they have access with our dashboard called EO Discover. It kind of summarizes, that's what we were showing earlier, kind of a bird's eye view of the overall system. So you can track, not just, where the points of interest are and the progress of the investigation, but then also the repairs, which is nice. Also, you have the ability to download that image, download that data, those points of interest. So that way you keep it forever. I kind of think of our technology as kind of proactively going to the dentist to have your teeth cleaned. The whole idea is, just because you go to a point of interest and don't find a leak that you have to dig up, doesn't mean, one, there's not a leak there, much like you go to a dentist and they say, I see a cavity here. We're going to keep an eye on it, and just because you didn't get something drilled into your teeth, didn't mean it was a failed trip or a waste of time. It's really, proactively going out there and investigating these different points of interest and then keeping an eye on them in the future. The whole idea is to fix a leak before it becomes, or fix a tooth before it becomes a root canal, is the idea. But, the data can then also be downloaded, all those points of interest. Although the EO Discover is a 12-month subscription, and as well as the UCollect app, which is what the Boots on the Ground team uses, all of that data can be, uploaded back into their Esri, Diamond Maps, whatever their GIS platform they're using. So that way they keep the data forever. But EO Discover itself is really a 12-month subscription. It's really meant to be the actual investigation, and usually that's wrapped up well within the 12 months. And then the idea is, just like anything else, once we start on this journey, it's like eating healthy or going to the gym. As soon as you stop, you're going to be right back where you were. Same thing with non-revenue water. If we stop, proactively trying to find leaks, well, it's going to go back to where you were at. So the whole idea is, future cadence of, future scans and keeping that, that activity open where you can use it. But you can always download the information and keep it forever.
So Eric, has Astera done any work on like a military base? And if so, are there any, do you have to get approval from the DoD to be able to, do a satellite scan? You could probably get a satellite scan from the Russians, but what's the process for military bases?
Yeah, and I completely understand their concern. But the fact of the matter is, these are, whether they be state, countries, they can use synthetic aperture radar. They could be taken at any moment without anyone's knowledge. I mean, it's could be used for nefarious means, and they could just they don't need the approval. They're in space. Famously, the balloon that flew over the U.S. a few years ago actually had synthetic aperture radar on it. So, yes, yeah, they certainly can. But yeah, a lot of times it does. The security gets a little, and understandably, concerned. And we just tell them, look, if we really wanted to do something nefarious, we would just take an image. We wouldn't need this. So that's the fact of the matter. I mean, I hate to say it like that, but it's true.
But you have done some Army bases in the past?
Oh, absolutely. We've done in Hawaii. We've done some stuff in the midsection of the U.S. as well. Yeah, and you can imagine, military bases, their priorities are elsewhere. It's not necessarily water systems, so a lot of these haven't been touched for decades, and they really, really need the help. And we've had, wonderful results. I think with the one in Hawaii, I think we've done 3 services for them already. And that was a base that was probably built in the 1920s, 1930s. By far the most beautiful base I've ever seen. I was actually there. Gorgeous, absolutely gorgeous.
So you mentioned that the satellite image, each image can cover an area of about 1,000 square miles. With smaller utilities, they may not be able to afford the cost of a satellite survey. Can multiple small utilities kind of band together and collaborate and, buy a service, together? Is that something you guys have done in the past?
Yeah, absolutely. Like you said, it's actually all the way up to 1,400 square miles. So the opportunity to share that investment, not just with, recover and wastewater, but then as Gary mentioned, dams and levees can share the same image. It's all the exact same imagery. We just analyze the data differently. So yes, and that's the smaller utilities that really need it the most. They don't have, typically they're purchasing their water or purchasing it from someone that purchased it. So their cost of water is much, much higher. Plus with the satellite scan, you can imagine, it's a big, upfront cost. And, we have a certain level, about 250 to 300 linear miles of pipe. The price is going to be the same. So some of these smaller utilities, 75 miles, 100 miles, we can help them with. We've seen some utilities that are 14 miles or, but at that point, you get to a point where it's just walk the system. There's no point of us triaging your system and saying which part, 15 miles, if that's your system, walk it, have someone come in and do that because that's best served.
Can the system also detect, leaks from a sewer system?
Yeah. So we can see the leaks outside. We can see extrusion. We cannot see intrusion. I know a lot of treatment plants, they care more about intrusion. Me as a person in the community, I prefer extrusion to be seen. But yeah, we can help that, especially in the high force mains. We can see that. Again, we're just changing the algorithms of what they're looking for, changing that machine learning. Rather than potable water or groundwater, now we're changing it to what wastewater looks like and where we're seeing it. Obviously, the methods of verifying those leaks is quite a bit different. Usually it's larger diameter pipes. So, CCTV, smoke, things like that needs to be used.
Great. Well, boy, thanks to all the panelists. Appreciate you answering all the questions. We have about 66 questions. I tried to run through as many of them as I could. We will attempt to curate which ones have been answered and answer the rest of them. I really appreciate everybody's involvement from the panelist side, from our process people side, clicking buttons and doing all those kinds of things. I appreciate that, Catherine. And certainly appreciate all of you attending the webinar. Hopefully you have gotten your questions answered and gotten information. And we're exactly at 1 hour. So thank you very much. Appreciate it. Bye-bye.
Thank you.